So here is notes 8.5 day one. So this is your homework tonight, is finish this off. So feel free to fast forward up to whatever example I left off with your class. But basically the objectives on these notes are identifying the properties of logarithms. Once we know what they are, we're going to start using them to evaluate expressions. I want you guys to be able to identify the change of base formula. Identifying is basically just knowing what it looks like, and then being able to use a change of base formula on your to evaluate. All right, so the first part, we did this in class. So let's go ahead and move past that. Properties of logarithms. Um, so let me just open this up. Okay, so the properties of logarithms, there's three of them. First one was the product property. The product property said that if you take the log of a base of two numbers being multiplied, it's the same thing as splitting those two numbers up into two separate pieces and logging each of those pieces and then adding them together. Main way to remember this is that if there's multiplication, then you're going to be adding. It's very similar to um, the, the product of, my mind's going blank here, the product of powers. So quotient properties, like the quotient of powers, when you got division, one thing divided by another is the same thing as splitting it up into two separate logs and subtracting them. Power properties, if you have a power, it's just, you can bring that power to the front. It's the same thing as multiplying that times the original log right here. Okay, those are the three properties we went over, where they kind of how they came about and how the power properties actually related to the product property in class. So these notes I'll just kind of reserve for the actual things. And here, common mistake, you're not supposed to distribute to both of these. So we went over that in class 2. Let's open this one up. Okay, so log base 5 of, so this one, the way you would do this one is, since we got multiplication, we know that we're going to switch it into addition. So you take the log of both of these, so log base 5 of 25 plus, because it's multiplying, when you got multiplying, you're adding. So log base 5, so the 5s have to match here. Another log base 5 here. This only works when you have the same bases, so they're all log 5s of 125. So to evaluate these without using a calculator, you say, okay, 5 to the what power is 25? 5 squared is 25, so this part right here, that part evaluates into a 2 because 5 squared is 25. Plus this part right here, we're going to evaluate. So 5 to what power is 125? That's going to be a 3. So 2 plus 3 is a 5. And there you go. And it turns out 5 to the 5th power is the same thing as 25 times 125. Okay. This next part, I forgot, I didn't show you guys the change of base formula. But for this one, same kind of thing. But we have the power property. Since we have a power here, we can drop that power down to the front. So this is the same thing as 5 times log base 3 of 2. At this point in class, I think with 4th period, but not 5th period, but we stopped because log base 3 of 2, since we're working on simple evaluations here and I haven't shown you the change of base yet, 3 to what power is 2? There's no integer number that will be 3, negative 3 into a 2. So I'm okay with you guys just leaving it like this for now. Once we know how to do the change of base, though, you do have to do this out. Okay, so this one is another one where we have the power up here. So that's going to drop down. Once you see a power, you just drop it down to the front. So it's going to be a negative 4 times log of 10. Now, it is important that you remember when you don't have any log there, it's actually the common base, which is log 10. So no log there means that you should be imagining like there's a 10 there. So if you think of this as negative 4 times whatever this thing is, and this thing is 10 to what power is 10? 10 to the first power is 10. So it's negative 4 times 1, which is just a negative 4. Which makes sense because if you think of the 10 down here and you wanted to evaluate this just in your head, 10 to what power is 10 to the negative 4? Well, that'd be a negative 4 because 10 to the negative 4th is 10 to the negative 4th. Okay, next one. Whoa, there's nothing here. Oh, there you go. Okay, so for these type of problems are very common on standardized tests actually, because if you're taking a test where you're not allowed to use calculators, they give you values. So this part is actually given to you, and this part is given to you too. So they're telling you the log base 5 of 3 is about 0.683. So they're actually telling you that information. Now, if you want to check that in your calculators, 5 to this power is going to be about a 3. It's not going to be exact. That's why I put the approximation. Same thing here. 5 to this power is about a 7. Now, using this information, because they're telling you both of these, they want you to evaluate this. This is where those properties come into play. So since we actually know what the log base 5 of 3 is, and we know what the log base 5 of 7 is, or approximately what they are, our goal is to change these ones. So we're going to rewrite these so that they look like these things that we actually know. So a 21 can be written as log base 5, and a 21 is a 3 times a 7. The reason why I picked 3 and 7 is because I know what 3 and 7 are. I wouldn't pick 21 and 1 because I don't know those. So with this, since we have multiplication, I can now split these up into two parts. So I have log base 5 of 3 plus log base 5 of 7. Now if you notice, hope you guys can hear my daughter in the background. So we know this part is 0.683. And we know this part, log base 5 of 7, there it is, log base 5 of 7 is about 1.209. So this is equal to 0 point, or approximately, since these are all approximations, 683 plus log base 5 of 7 is 1.209. And this is going to be 9 plus 2, 3 is a 12, carry the 1, that's a 9, 8, 1.892. So 8, 9, yeah, okay, that looks good. All right, you can double check that. So here's how you would double check it. You would say 5 to that power. So to the power of 1.892. There's no 9 there. No, that's going to take too long. Okay, 5 to the 1.892 is equal to 21.0111, which is almost 21, close enough that it checks out. Okay, so let's try this other one. Good thing I moved that calculator, huh? So log base 5 of 3 over 7. Now we already have a 3 and a 7, so since it's dividing, we are now going to turn this into subtraction. So it's log base 5. Using our properties, we know the quotient property says that when you divide them, it turns into subtraction. So log base 5 of 3, it's the numerator minus the log of the denominator. So log base 5 of 7. Once again, we know what these are about. This one's about 0.683 minus log base 5 of 7 is 1.209. Since you guys are allowed to use calculators, so am I. 0.683 minus 1.209. There you go, 0.9. Right, and you will get equals 0.5, and I think that was 83, 0.526 negative 0.526. So to check our answers, that should be approximately the same as 3 over 7. So 3 over 7 is 0.4285. So 5 to the 0.526 negative is 0.4289. So very close. There you go. All right, last one, 49. Couple of different ways you can approach this one, but I'll show you guys just using, yeah, since we haven't used it yet. So let's turn this into log base 5, and 49 is a 7 squared. So 7 squared is this thing. Now, technically, you could turn this into 7 times 7, and then this will be a 7 times a 7, then split it out into two plus signs. But we don't need to do all that. We can bring this 2 down to the front. So this is equal to 2 times the log base 5 of 7. Now, since we know what log base 5 of 7 is, 2 times log of 7 is 1.209. Okay, so this is equal to 2 times 9 is 18. Carry the 1. That's a 0. That's a 1. 2 times 2 is 4. 2 times 1 is 2. Bring over 3 decimal. 2.418. Okay. And that's it. And then just double check that 5 to that should be about a 49. All right, so moving on. See how much time we got here. 503. Okay, change of base formula. Like the name suggests, we use this formula when we want to change a base. So let's say you had log base 7 or log base 8. It changes those. You may change any logarithm base to a new base using this formula. So just in case you don't like your old base, you can change it into a new one. Okay? And the way you do this is using this right here. So if you have a log base c, so remember c can be just about any number, just about, of u, the way you can change it to a new base is if you notice our base used to be a c here, but now with our new part, because it's equal to this, they changed into a b. So the old base was c, it changed into a new base b. So these just represent different numbers. Now if you notice, the u stayed the same up here. So with your old base, you take the u, log whatever your new base, whatever you want it to be of u, over log base, the new base that you want of your old base c. So c ends up right there. So let's go ahead and try this out with the one that we actually know. So you actually know the answer to this one already. 5 to what power is 25? The answer is 2. So we know it's a 2. But you can change this to any base you want. So this is where your calculators come into play, because you don't want, your calculator doesn't, or most calculators don't do a base 5, but we do know of 2 different bases that your calculators do. That's the log base 10, which is just the log button in your calculator, and the log base e, which is just the ln button in your calculator. So in actuality, we want to switch these to the common logarithm or the natural logarithm. That way you can plug it in your calculators. So according to this up here, the way we rewrite this is, let's use the ln button. So we can do ln of the u is where the 25 is, so ln of 25 over ln of your old base, which is a 5. Now we know it's going to be a 2, so let's hope that this ends up being a 2. Or I don't have to hope. I know, because it's math. Okay, so no hope necessary. And let's see here, ln of 25, so you do 25 ln, so that's what ln of 25 is, divided by, so if you look up here, it says ln of 25 divided by 5 ln. So this number is the 5 ln. So now when I hit equals, it's going to actually divide those out, which is 2. And there you go. 5 to the second power is 25. So it works the same thing with log. So let's try this with logs. Log, common logarithms. 25 over log of 5. It works with any base you want to change it to. This changes to base e, this changes to base 10. We can change it to a base 20 if we wanted to, but the thing is that the whole point here is that we want to try to make it something that we can plug into our calculators. Okay, so log of 25. So 25, so we're using log now. There it is. So that's the log of 25 divided by the log of 5. So 5 log, that's what the log of 5 is. So it's going to be this divided by that, and that is also a 2. Okay, that's how the change of base formula works. So let's try it out. So log base 3 of 7. The way you're going to do this is, now I do realize some of your calculators you can actually plug in the new base, but in the directions, because I want you guys to know how to use this base formula, if it says use a change of base formula, you have to show me what you guys are going to be turning it into. So you do have to make a new quotient here. Now, I don't mind if you guys use the log base 10 button in your calculators, the common logarithm, or the natural logarithm, whichever one you guys feel more comfortable doing. So either one, you're going to get the same answer. I'll go ahead and use ln for no other reason than it has, for no reason. I don't know why. Okay, so ln ln. So I changed, my old base was a 3. I want to change it to my natural base now. So my natural base, log base e. Now the biggest part where people mess up here is where to put the 7 and the 3. The 7 goes on the top and the 3 goes on the bottom. One way to kind of think about that is it kind of looks like if you were to think of this like a fraction, it already looks like the 7's going to be on top. So just kind of go with that. Okay. Um, and that's kind of like a lame way of thinking about it, but just, it looks like it's the top, so put it on top. That doesn't always work that way with other types of equations, but with this one it does. So log base 7 of 3 over log or over ln 3. So you just plug that in your calculators. So, whoops, wrong one. 7 ln divided by 3 ln equals 1.7712. So approximately 1.7712. I do want you guys rounding off to about 4 decimal places. So let's double check this. 3 to the 1.7712 is 6.99999999663, blah, 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 which is really, really close to 7. That's why we have the approximation symbols. Okay, next one, 4 to what power is an 8? Same thing here. Just because we use ln over here, I'm going to use a log base 10 here. So log of 8 over log of 4 is approximately, and then you just use your handy dandy calculator, 8 log divided by 4 log equals 1.5. So 4 to the 1.5 equals an 8, and that looks good already. So we'll to the 1.5 equals 8. All right. Be careful not to switch these. You can't use a log 8 with an ln 4 because it won't get you 1.5 if you watch right here. So 8, so let's do 8 log divided by 4 ln. So we're mixing the log base 10s with log base e's, and you get something totally different. So yeah, you can't use both of them. You have to make sure that your new base that you're changing it to is the same on the top and the bottom. And that is it. So this is what I was going to assign you, but I'm not going to assign you this tomorrow because we're going to go over a couple more notes. So it's going to be modified from this. So don't do those. And yeah, so if you have any questions about any of this, just make sure you let me know tomorrow during class. And that's all. Okay, bye-bye.